So in this video, I'm going to explain the homework for 3.3. So with graphing systems of inequalities, it's always a good idea to get the equations in slope-intercept form. So this one, we would have y is greater than negative x plus 1. And this one, we'd have to, I'm going to do down here, we'd have to add 2x to both sides. So 3y is greater than or equal to 2x minus 6. And then divide by 3, divide everything by 3, so we get 2/3 x minus 6 divided by 3 is 2. So now I can look for this one. And notice all the lines are in the same place, so it's just a matter of the shading and whether they are dashed or solid lines. So this first one, negative x plus 1, but it's going to be a dashed line because of the strict inequality. So it can't be A, it's got to be B or C. But then C, they're both dashed. And in number 1, we have a mix. We have the first one's dashed, the second one's solid. So it automatically has to be B. B is number 1. And the shading, we can just check to make sure it matches up. We're going to be above this line and above the other line. So above both lines would be this region. Okay, number 2, we can do, again, y is less than negative x plus 1, and it's a strict inequality, so that rules out A. It has to be C. I don't really even have to check anything else. It must be this one because of process of elimination. So that means 3 has to be A without even really doing much work there. So going down, now we have to graph these lines. So x is greater than negative 1 means we have a dashed line going right through where x is negative 1. And we're going to shade to the right. And then we have a horizontal line. Let me switch colors. I guess I can't switch colors in this. So I'll just pretend like I'm using a pencil. It's all the same color. And we're going to shade above both of these. Well, above the horizontal line and to the right of the vertical line. So it's really only going to be this area, all of this. Okay. So then the next one, x is greater than negative 2, greater than or equal to. So now my line should be a solid line. I'm going to shade all the way to the right of it. But I'm going to wait until I get the other line on there. Y is less than positive 1. So less than the horizontal line, and to the right of the vertical line would be all of this. All of this. Okay, number 6. Y is less than or equal to 3 would be right here. And y is greater than 1. So dashed line. Oops, that's not in the right spot. That is at negative 1. We don't want to make that mistake. So y is greater than positive 1 would be up here. So greater than positive 1, less than negative 3, that's everything in between here. Okay. Moving on. Number 7 you had to do. So I'm going to put these in slope-intercept form. Y is greater than or equal to negative x if I just subtract x on both sides. So that line would go right through the origin and have a slope of negative 1. So it's just going to go down here, 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 and up here, and here, and here, and here. And it's greater than or equal to, so solid line. Next one, I'm just going to add x to both sides and get y is greater than or equal to x. So that's just going to be this line going the opposite direction. And now if we're shading above both of these, the overlapping region would be here. Okay. Next one we had to do was number 8, I believe. Let me just go to my Google Classroom and make sure. Okay, yes, number 8. So this one's already in slope-intercept form, so it goes, if there's no y-intercept, it goes through the origin. Slope of -2 this time, so we have to go down to right 1, down to right 1, up to left 1, up to left 1. So this line should be sloping from left to right. It should be going downhill. And it should be a dashed line because it's a strict inequality. Then I'm going to shade above that line, so that would be over here. The next line, I'm going to actually add y to both sides so that I don't have to worry about switching the inequality. So that's going to be 2x is greater than 1 plus y, and then I'm going to subtract 1 on the other side. So 2x minus 1 is greater than y. Or we can read it the other way around. Y is less than 2x minus 1. So y-intercept is -1. And then positive 2 is the slope. So 1, 2 over 1, 1, 2 over 1. And this is also a strict inequality. So we should have dashed line, kind of like an X right through here. Now, where do we shade? We shade above the first line, and we shade below the second line, because it says y is less than. So above the first line, but below the second line would only be this region. So this is probably the first tricky one, where this is really, if you're using two different colors on your shading, the overlap should only be right here. So only the points in this region will satisfy this system, and none of the points on the boundary line. So if I asked you a question about one of the boundaries, like does the point 0, 0 satisfy this system? Is the point 0, 0 a solution? We could just plug it in to both x and y. Is 0 greater than or equal to 0? No, it's not. And then we can plug in x, 0 in for x and y here, and we get 0 minus 0 is greater than 1. Is 0 greater than 1? No. So the point 0, 0 is not a solution. That's just an exam kind of question I could ask you. Okay, the next one we had to do is number 10. So this one, it might help to use the x and y intercepts. If you notice, we're in standard form, and there's a lot of common factors. So I can already see the x-intercept would be 2 if I plug in 0 for y. So there's going to be a x-intercept right there. And the y-intercept would be 1 if I divide by 2 on both sides. So I can tell my line has to go through those 2 points like this. The second one, if I plug in 0 for y, divide both sides by 3, I get x equals 1 and y equals 3. 3. So that line has to go through those 2 points. That was pretty bad. Let me try that again. So there's the second line. Now, where do we shade? Really, it's hard to tell by, these both are pointing less than right now, but they don't necessarily have to be that way when you put it in slope-intercept form. Although we can see if we just move the x's to the other side, the y is going to have the less than symbol pointing at it. So we are going to shade below both of these lines. And if you shade below both of them, the overlap would be this big region over here. All of this, that would be below both of them. So nothing over here or here or here. Okay, and the last one that you had to do was number 14. I don't know if you noticed, but I purposely skipped these ones that were scaled by 2s just because they're very annoying. So number 14, I'm going to graph this one first. Y is greater than or equal to 0 would be this. We're going to shade above that. And then these, I'm going to put them in slope-intercept form. Y is greater than negative x minus 2. So minus 2, and then a negative slope of 1 would be like this. So dashed line. Okay, and then the second one, just add x to both sides. We get y is greater than x minus 2. So that's the same y-intercept, but the slope is going the opposite direction. So it makes another kind of x here. Now, where's the shading? Above the horizontal line and above both of the other lines. So above the horizontal means there can't be any shading down below here. So even though it says above the other lines, this triangle region should not be shaded. It should not be the overlapping region. It's only going to be this region up here. All of this.